All right, I'm going to just go over one of the problems to make sure that you all can practice these over the weekends so that you feel comfortable with the percent composition. Remember, the test is on Tuesday, and it'll be all those mole conversions and the percent composition, and you will not be able to use the mole roadmap on the test. So let's just try number 1 here with magnesium and nitrogen. So it says calculate the percent composition of the compounds that are formed from these reactions. Now, we are given 9.03 grams of magnesium and 3.48 grams of nitrogen. It says it combines completely. Now, if you remember when we did combination reactions, it's saying that if I put those two things together, that would be my product. So if you remember the law of conservation of mass, the idea is that if I start with 9.03 grams of magnesium and 3.48 grams of nitrogen, if I combine them, I would have a total mass of my product as adding the two products together. So it would be 9.03 grams of magnesium plus 3.48 grams of nitrogen. So the total mass there would be, make sure you have your calculators out, 12.51 grams of whatever that product would be. Now, you guys have done a combination reaction. You could probably tell me what the product is, knowing that magnesium's a metal with a +2 charge, nitrogen's a non-metal with a -3 charge, but let's, for intents and purposes, let's just look at what we're given here with our masses to try to figure out what the percent composition of magnesium is in this product and the percent composition of nitrogen is in this product with the information and tools that we have. Okay, so our total mass, I'm just going to write it here so I can have some extra space, is 12.51 grams. Now, to figure out the percent composition of magnesium in that product, I'm going to take the 9.03 grams of magnesium over the 12.51 grams of your total times 100. It's going to give me my percent magnesium. What do you get for that? And then for your product, you could do for your nitrogen, you could do either 100 minus whatever that percent is, or you could go through the whole calculation. So these are pretty easy kinds of calculations. For this one, you should get 72.2% magnesium. If you were to do the nitrogen, it would be the same similar setup. 3.48 grams over the 12.51 grams. I'm just going to get my whiteboard out here. 3.48 grams of nitrogen over the 12.51 grams of your total times 100. And so you could either do 100 minus 72.2 to get your answer, or you could do this division. And so the percent of nitrogen would be equal to 27.8%, and that's all you have to do for this problem. This is somewhat useful to us, but it's not as useful as trying to determine from some given amounts the actual chemical formula for this product. Now, we have done work in combination reactions, magnesium being a +2, nitrogen being a -3, that we could determine what the formula is, but let's pretend all we have given is this problem in number 1. Now, this problem didn't specifically ask for it, but I'm going to put an extra credit question on the test that has you calculating the chemical formula based on being given masses. So I'm given 9.03 grams of magnesium. We know, using our periodic table, we could look at the molar mass of magnesium, and the molar mass is 24.305, and it equals 1 mole. So I can determine the number of moles of magnesium, and that would come out to be 0.3715 moles. see that I'm carrying it out pretty far actually. We can do the same thing for nitrogen. The molar mass of nitrogen is 14.007 grams. It's 1 mole. The number of moles of nitrogen then becomes 0.2484 moles of nitrogen. And again, this work is really just going to be how the extra credit will look on the test on Tuesday. You could still use 9.03 grams of magnesium over your total mass to find your percent composition. But I'm trying to show you another way where if I'm given masses, I can actually determine what the formula would be. And it's another way to show you how to get formula than just magnesium and nitrogen combined, because magnesium has a +2 and nitrogen has a -3. Okay? So once you're to this point with using the molar masses, what you're going to do is you're going to take your smaller number, so in this case the 0.2484 moles of nitrogen, and you're going to divide it by the smaller number. And then notice how you get 1. Okay? You're going to then take your smaller number and you're going to use that to find how many times more does the larger element, in this case magnesium, go into that smaller number. So in this case, it's a 1-to-1 ratio for nitrogen, obviously. And then for magnesium, you get 0.3715 divided by the smaller number, which is 0.2484, and you get that to be 1.5 moles of magnesium. So the ratio here of magnesium to nitrogen is a 1.5 to 1. Okay, we know when we make chemical formulas, you put magnesium metals come first, and so you would do this. Now that doesn't look totally right to us because we never use our subscripts as a decimal, because I can't have part of a particle in that formula, and I don't need to write the 1. So I have to find a way to get rid of the decimal. Well, fortunately for me, it's 1.5. So if I multiply them both by 2, I would get Mg3N2, and that would be the chemical formula that I figured out from being given the masses. If you note, like we talked about in first semester, magnesium in group 2, nitrogen in group 3, in order to neutralize the electron transfer, you get Mg3N2. So this is just another way to find out the formula, being given amounts of the substances. Okay, and again, this kind of problem, taking amounts and finding the formulas, would be an extra credit question. Just finding straight percent composition of a compound will be on the test, along with mole conversions. So happy practicing. If you need help on anything, there's an additional resource on my DSHA, and I hope you all have a wonderful weekend. All right, bye.